2 minutes, 1 minute to go, guys. Get excited. Okay, 11:10, we're going to start on time because we've got a really exciting session today. So for those that actually don't know me, my name is Andrea Hosey and I'm the Vice President of Member Engagement for the ICME globally. And I'm really, really excited to be welcoming you on behalf of Future Fuels CRC, AGIT, Chemeca and the ICME to this very first Chemeca pitch session. So before we start, we couldn't make this possible without the support of our sponsors. So I'd like to say a big thank you to Future Fuels CRC, to David Norman and Sean Coffrey for their support, and to AGIT, to Jen Thompson. But behind that, there's been a great piece of work by the committee. So thank you to George Wild, Sandra Kentish, and Hugh Barlow. Fantastic effort. But there's a special thanks to Benji Lee and to Catherine MacDonald as our chair of the committee and Benji as our CRC representative. Both have brought a fantastic energy to this competition, and their leadership, which I talked about yesterday, has been fabulous to get us to this point. Very short time now, so we are going to be running the pitches very quickly. There's going to be a quick turnaround for the excitement. The teams know their order. I'll be calling them up to the stage. They have 7 minutes to present to you. They will then have a round of questions from our judges. So thank you to our judges sitting in the centre here. We have David Bogle, the current president of the ICME, who's here from the UK. Sandra Lau, who's the alternative fuel manager for Viva Energy, and Benji Lee on behalf of Future Fuels. So thank you for your efforts. To the teams, you have 7 minutes to talk. Sandra is here. She will give you the signal at the 1 minute. And then at the 7 minutes, I'll come up on the stage and move you along to answer your questions. At the end of the time, can you pay attention to Hugh, who will sort of ferry you off the stage. So I think that's all from me, apart from to wish you all a great time. Enjoy it. We're really excited to see what you're going to present today. So without further ado, the first team to present is Future from the University of New South Wales. Welcome to the stage.
Testing. Fossil fuels are changing the world. Electricity costs have almost doubled over the past year. Our resources are depleting, and coal has around 130 more years of support left. Our climate is seeing a 0.2 degree increase per decade. Australia must transition its current reliance on fossil fuels into clean and carbon neutral fuels. We must secure Australia's quality of life for future generations. We at Future aim to drive this change in Australia to create clean, sustainable, and cost-competitive hydrogen for all. Green hydrogen is an innovative global renewable energy. It only emits water and can support transportation and heavy machinery as an alternative fuel.
However, to meet Australia's proposed 2030 emissions target, current green hydrogen technology will need at least 5.5 billion litres of clean water annually. To overcome the reliance on vital clean water, Future proposes the establishment of a new green hydrogen facility in the Hunter Valley, a New South Wales regional hub. Future's facility will be fed by glucose-containing wastewater from nearby wineries and renewable electricity from nearby solar and wind farms, which in turn will produce hydrogen gas and a value-added byproduct, glucaric acid. Additionally, the use of nickel electrodes will reduce reliance on expensive materials like platinum, further enhancing financial and environmental sustainability. In the first 10 years of the implementation strategy, we plan to distribute hydrogen to 3 key end users. Firstly, heavy machinery in the mining industry. We plan to truck around 1,800 tonnes per annum to 3 Hunter Valley mine sites to fuel mining trucks. Secondly, buses. The Rover depot, located 4.1 kilometres from the production site, will be transformed to a refuelling station to fuel 60 hydrogen buses. Lastly, injecting a 10% hydrogen blend into the Hunter natural gas pipeline to provide home within the region with a source of renewable energy.
The conduction of economic analysis found that our levelised cost of hydrogen produced at this facility would be $3 per kilogram, which is 21% lower than an equivalent hydrogen project within Australia. Furthermore, a total investment of $61 million and a payback period of 9 years was calculated. This would mean that by investing $18 million in our project, Venue will be able to receive an internal rate of return of around 9%.
The implementation of our solution was met by various challenges. Firstly, the seasonality of the wine production. However, this will be overcome by including late harvest grape for sweet wine production. And if this isn't available, as a last resort, we'll use cessnock wastewater to feed the process. Secondly, the variability of the glucose content. This will be managed by real-time monitoring and dilution of the feed water to maintain the glucose concentration set point. Lastly, by gauging the opinions of 6 industry delegates here at Chemeca, the feasibility of our plan to retrofit the natural gas pipeline for 100% distribution was brought into question. And as such, we decided against this.
So after this initial plan within the Hunter region, we then aim to expand to other wine regions within Australia and New Zealand, with the opportunity to reach a cumulative annual production of more than 500,000 tonnes of hydrogen. This hydrogen will support the energy transition for buses and heavy machinery within the established regional hubs. This will also allow us to scale up to heavy freight trucks, and as the hubs have been strategically placed along Australia's primary arterial freight routes, such as the Hume and Stewart Highway. Our production, distribution and utilisation of hydrogen falls within decades of international and Australian hydrogen standards. Stakeholder engagement with emergency personnel and local communities are also a delivery priority for us.
Future is embracing disruptive technologies within process safety, such as automation, artificial intelligence, and the Internet of Things. This will also help with reliability and scalability. Firstly, insights from multiple professionals, including the keynote speaker at Chemeca, outline that human involvement introduces potentially catastrophic safety hazards. Subsequently, we want to automate emergency shutdowns and incident response systems. The innovative leap after that automation is a machine learning-powered digital twin model, which will be developed shortly after our 10-year break-even point. This will be used to inform future process optimization and scalability, and we can use live and historical data from internet-connected sensors. This will inform efficiency bottlenecks and long-term infrastructure expansion. We're changing technology from decision support to decision-making. We also acknowledge that there are key ethical challenges with hydrogen: social acceptance, workforce changes. However, there are 2 unique ethical challenges that we face. Firstly, the use of automation and AI prediction technologies introduces complexity into who the liability sits with in a safety incident. Who is responsible if a protective system fails? Is it the operator, the designer, or the regulator? Secondly, government-funded projects often come under public scrutiny. Approval from local communities and field users is important to us. Limited social acceptance of hydrogen may lead to public disapproval for our project versus perceivably more ethical investments such as a new hospital.
Overall, our proposal aligns with 16 strategies and initiatives within the Australian federal and state governments, including the New South Wales Hydrogen Strategy and Australia's National Hydrogen Strategy. These strategies support our proposal by encouraging partnerships between stakeholders such as mining companies, bus companies, and communities. They also incentivise markets and stakeholders into reducing emissions by providing benefits to those who commit to this energy transition. A clear gap within these policies, however, is the government's commitment to reskilling people from the established energy sector into new industries.
Future is invested in delivering this with your direct funding support for a more sustainable Australia. We believe that our infrastructure developments can mutually benefit Venue as we are supporting communities. This initially starts with 40 new jobs in the Hunter region, then scaling up to reduce 131 million tonnes of CO2. That's equivalent to removing 28 million diesel vehicles from Australian roads.
That's cool. That's cool.
The whole team, would you like to all stand in the middle? And the judges, so. Whoa. First good proposition. So what do Venue think? So.
It's Benji Lee here from the Future Fuels CRC. Well done on an amazing presentation. Knocked my socks off. Just a question that I wanted to ask, really around, I guess, the decision not to use the pipeline infrastructure based on a survey of a few people. Just questioning whether that's enough weight, when, there is, I guess, the potential to get scale through leveraging infrastructure. What's your view on just, I guess, making a decision like that based on just stakeholder input alone?
Yeah, thanks for the question, Benji. So initially our plan was to retrofit the pipeline from our facility to the Rover bus depot 4.1 kilometres away. However, upon consultation with some of the industry professionals here, we didn't feel we had enough confidence, like it wasn't unanimous. So we thought there's still too much risk associated with such, I guess, a monumental decision. So at this point in time, we were just going to stick to a 10% blend in the Hunter network.
Thank you.
Hi, it's David Bogle here. So, quick question. This is very much based around quite a rural area with major infrastructure development. How do you think they will respond to such a significant activity and change in the way they work?
Yep, so we're going to be located at the Cessnock wastewater facility, which is quite a large ground and with already existing infrastructure in place. So and it's quite removed from the surrounding community. So we imagine there wouldn't be too much pushback from the local government, but this is something that we're going to have to consult with as we move forward.
Sorry, Sandra here, one question. Given your projections for $1 per kilogram cost and your overall project costs are better than what is being put out in industry at the moment, what makes your project so different and so much more financially sound versus all the other projects in Australia?
So thanks for the question, by the way. Our project differs in, I guess, two key aspects and one sort of peripheral aspect. So firstly, because we're oxidizing glucose on the anode, that actually reduces the potential required by about, I think, 0.3 volts. So first of all, we're saving quite significant electricity costs. Second of all, instead of using high purity water for conventional water splitting, we're using wastewater. So there's another cost saving. And furthermore, we found that our electrolyzer or our plant is 40 megawatts. We found this was the sweet spot in terms of economies of scale.
Just a follow-up question.
Sorry. And sorry, we don't have time for audience questions, so thank you to Team
Thank you.
Future. Can you exit stage left? And, yeah, sorry. And I'd like to invite the next team, Team Hydrogen from WA, the University of WA. Welcome to the stage.
Hello everyone. So my name is Jason. I'm the team captain for Team Hydrogen. I'm joined here today by Raymond, Albert and Vicky. So why hydrogen? So hydrogen, we believe that hydrogen will be the most effective solution to the problem that was provided to us. The reason why we believe that this is the case is because we know that hydrogen is a low carbon energy source and that it only produces water when combusted. We believe that hydrogen will enable the decarbonisation of sectors that are highly energy intensive, in particular the heavy land-based transport industry. We also believe that hydrogen is a highly reliable energy source, and through funding from the WA state government, we believe that we will be able to deliver an innovative solution and move towards a more sustainable future.
Karratha being called the power hub of Australia with petroleum industry, gas and mining exploration sites, it is also located in the northwest coast, which is feasible for core exploration among the area surrounding Karratha. So we have chosen to transport hydrogen blends with LNG pipelines rather than having multiple hydrogen production sites in Perth, which cuts down the cost. This region allows easier progression to the surrounding regions like Port Hedland and Newman. It has strong industrial presence with Woodside, Yara, and Rio Tinto, who can use the existing natural gas infrastructure. Overall, it's a prime location which allows future expansion to Perth.
So our proposed solution is a multi-stage process to incorporate flexibility and technological advancements. So starting with the first stage, we want to have an initial base structure located within Karratha, and within this area, we can have easily enough one electrolyzer to support the economy within that region. And with future expands, we want to look at using a Dampier to Bunbury natural gas pipeline to provide hydrogen to Perth. And with this, we want to incorporate an 8% blend in that pipeline because that's what it can do from previous research. And with this previous expansion as well, we want to incorporate the Fortescue River natural gas pipeline and the Pilbara Energy gas pipeline to distribute to Newman and Port Hedland, creating a triangle of operations situated within the picture with the red triangle. And with any increased production of hydrogen and there's dedicated long-term stakeholders, we can incorporate a dedicated hydrogen pipeline when there's future technological advancements. And with improving infrastructure, the current pre-existing infrastructure can take upon 8% blends. But with that, we also have to look at the substations, data analytics, and communications within the whole entire region of WA that have to take on this new blend. We have to ensure this blend stays beneath 8% in order to make sure there's no metal degradation. And as well as that, within the region, there's lots of industry uses. We have ammonia production companies like Yara and CBSP, which we would love to have renewable hydrogen incorporated within their production. As well as that, within our triangle of operations, we can incorporate hydrogen refueling centers for vehicles and machinery to be accessible. As well as that, mining facilities like Rio Tinto, Roy Hill, and FMG would be able to easily access these facilities in order to incorporate it within their operations. And with this as an end result, we want to make sure that our prices stay within around the $2 per kilo to make sure it's competitive for the market. There might be a limit on what we can produce, but as long as this price stays competitive, we can ensure that these renewable hydrogen production can stay something what companies would want.
So at first we weren't 100% sure about the feasibility associated with introducing hydrogen into these pipelines. So we decided to do a little bit of research and actually reached out to some industry professionals at this conference. And what we actually found was that 75% of respondents agreed that it is realistic to have 10% of hydrogen in the Bunbury Dampier natural gas pipeline by 2030, which is consistent with the timeline that we have proposed. In addition to that, what we actually found was that 45% of respondents agreed that there will be a dedicated hydrogen transmission network built involving the Bunbury Dampier pipeline by 2050. And what this means is that further research and further technological developments will need to be done before we actually incorporate a complete hydrogen network.
So there are also various other uses for the fuel, such as a fuel stock in a wide range of chemical synthesis applications, and to decarbonize blast furnaces, as well as in power generation applications involving gas turbines. And as you can see in this figure, the projected global hydrogen demand is expected to increase over time. So with these uses, as well as many others that will come over time, we're sure that the demand will be great in the future. And in terms of the required new infrastructure, we will be sourcing hydrogen from an electrolysis plant. As an example, we could be using the NG Yara renewable hydrogen plant. We'll also have refueling stations, which will have dispensers, compressors, meters, and other equipment. And we'll also use these refueling stations to meet end user hydrogen performance requirements, which will require new technologies through research over time. And lastly, we'll have connecting pipelines to connect the DBNGP to hydrogen sources.
With process and personal safety being a main concern with hydrogen gas, it is a DG class 2.1 substance within WA, and with this it has a low ignition energy, means it can be inadvertently ignited easily, and it has a high flammability. And with the main concern of hydrogen, we've got to keep in mind the general public will be accessing these refueling stations. So compared to your general operators on your production sites, they won't know your standing instructions or your working orders. So we've got to keep in mind we want these refueling stations to be alarmed, so then our prevention controls will be able to save we'll be able to make sure that the general public stays safe, and the image of hydrogen gas will be a positive on the environment.
Thanks.
Thank you to the team.
Thank you very much, Team Hydrogen. So how do Venue feel about that? Can I ask for some questions from the judges, please?
How much money are you after?
So in terms of how much money we're after, with our proposal, it's very flexible in terms of what the stakeholders need, so we've got to cater for the stakeholders. So with the blending, we do have to set up an electrolyzer within Carafa region, and with that we're estimating around the $10 to $11 million mark with that electrolyzer proposal. But keeping in mind with the stakeholders, we need to keep in mind that the prices need to be competitive, so we don't want to go overboard in terms of what we put in the pipeline. We just want to ensure a competitive price to keep our stakeholders like ammonia and chemical production companies happy with the $2 price range that we provide.
Benji Lee here. Well, yeah, well done, and I'm really impressed by, I guess, your focus on existing infrastructure. The 8% level is interesting. I guess what's got to work into the future around scale is more the 100%. So do you see, what sort of opportunities do you see for moving in those sort of leaps in scale?
Just testing the mic here, awesome. Yeah, so we do see a lot of opportunity to move towards a 100% hydrogen future. So we do recognise that current natural gas pipelines won't be able to take on 100% hydrogen flow, which means that that would require the construction of an entirely new natural gas pipeline. And we understand that's going to take a lot of time. We also understand that it's going to take a lot of time to get confidence from companies and other organisations in us before we actually move towards that option. So whilst that's sort of like a long-term goal, it's not something that we are looking at in the immediate future.
Do we have time for one last question from David? Okay.
So perhaps you could tell us a bit about how you might, what might be the pathway from the small to 100%, which is that's probably enough for me.
So for the pathway, so we know that we'd have to do a project like that in stages, because obviously we need to make sure that we are supplying reliable gas to all of our customers at all times. So that means that we'll do it at stages. And the way that I see us doing it is to start off between Port Hedland and Carafa, because that's where all the industry is, and we'll be able to get the industry support there. And then based on successful projects, we would be able to build further pipelines for 100% hydrogen and expand to other regions of Western Australia.
Okay, thank you, Team Hydrogen. Thank you. So I'd now like to invite to the stage the future shapers from Monash University. Oh, sorry, University of Melbourne, sorry, just checking with you, sorry.
take this. Oh, just click it. The steelmaking industry consumes 5.9% of the available global energy available and contributes up to 9% of the total global CO2 emissions. Despite this significant contribution, it has been long overlooked for carbon reductions in our pathway to net zero. Nevertheless, many sustainable infrastructures and recycling facilities depend on these steel-based products. Therefore, it is essential for us to transform this steel industry to achieve a sustainable future from a fundamental level. We perceive this as an opportunity, alongside with the mining industry, who are not only just high emitters, but also high diesel fuel consumers. While there is high debate and competition between fuel and battery in powering light-duty vehicles, battery technology does not suit powering heavy-duty machinery due to its short range, long charging times, and the requirements to replace each machinery, which would incur high costs. Thus, a sustainable solution that powers the industry with equivalent energy levels and costs must be proposed. As we've learned throughout this conference, our solution radically rethinks the way we design, build, and work together to reach our net zero targets by 2050. I'll pass it on to Gianna to talk about the solution.
Power to liquid is a central idea of our solution, in which green hydrogen is combined with CO2 emissions from the hard-to-abate steelmaking industry in Port Kembla, New South Wales, to produce sustainable diesel. Our location is strategically located in Port Kembla, which is a heavy industry precinct. And in addition to that, Port Kembla has an excellent hydrogen track record in its hydrogen supply chain. We believe that these can help to de-risk major projects like ours, which involve large-scale hydrogen production and storage of hazardous chemicals. Sorry. So our solution is a phased approach. In phase 1, we target local diesel demand of collieries heavy machineries and coal haulage around Port Kembla. In phase 2, we attempt to valorize all capturable CO2 emissions from the steelmaking industry to take advantage of economies of scale. The successful implementation of our technology is the key to rolling out disruptive power-to-liquid solutions nationwide at regions where there are viable point CO2 sources. Through this conference, we learned that project delivery in a brownfield environment is extremely risky due to its highly constrained and dynamic environment. The use of these existing point CO2 sources will inevitably entail brownfield project delivery. Therefore, stakeholder engagement at the early stage is very critical. I will now pass on to the next speaker who will talk about the benefits that can be brought about by the current project.
Thank you, Gianna. So the extent of CO2 reduction of this project is truly amazing. In phase 2, we can avoid up to 1.6 million tons per year of CO2 being released to the atmosphere. It is equivalent to decarbonize 30% of steelworks' annual steel productions, or equivalent to planting 2.8 million trees per year. On the other hand, from the life cycle perspective, power-to-liquid diesel can achieve significant CO2 reductions compared to equivalent fossil-based diesel. So for this project, we believe there's many leverage. Firstly, power-to-liquid diesel can be used in existing mining fleet, transport, and machineries. Secondly, existing infrastructure of diesel storage and distribution can remain in use. Thirdly, the project can also use surplus water in region that is currently being discarded to the oceans every year. In our feasibility study, we found out that the electrolyzer incurs significantly for site, whereas land is prohibitive. Therefore, there's a potential to leverage gas pipeline for bulk transportation of hydrogen in the future. From industry opinions, hydrogen pipeline need to be micromanaged in segments to ensure safety and operative. Now I would like to pass on to Jackie for financial plans.
Thanks. So we estimated the project is going to be financially viable and can deliver attractive returns for the investors. Like many of the other energy transition projects we've learned from Chemeca, our project requires a large upfront capital cost, and we estimate that to be $491 million. And despite the large capital cost, we found that the project is not only feasible, but also attractive from our feasibility studies. And the way how we did it is to split it into 2 phases. So for phase 1, that will cover the first 5 years of construction and operations. And the return is going to be 25%, and the payback period is 3 years. And for phase 2, that will cover the remaining 20 years of the operation, and the return on investment is going to be 23%. And we also found the project returns are much more attractive than standard industry, which is 9 to 16%. And we found the project NPV is going to be $283 million. Therefore, we believe that this project is going to be a likely candidate for external grant funding, which will contribute to its financial attractiveness. And we found that the potential fundings can come through New South Wales Government, Commonwealth, and also BlueScope, and many more to come. And we also assess the risks involved with the project, and we believe that we can mitigate and minimize the risk. I will pass on to Michael. Thanks.
Thank you, Jackie. Now, a range of policy initiatives at various stages of proposal will help us capture certain sections of this market and ensure transition. Now, if decarbonisation mandates are introduced at the state and federal level, then we can effectively guarantee a more reliable industry partner relationship to be established. Especially if these initiatives are introduced at the state and federal level, and especially if they are introduced for high polluting industries such as mineral processing. Likewise, fuel switching mandates, like those introduced for biodiesel with the Queensland government, can effectively guarantee the transition of industry towards sustainable fuels. And this approach has been widely successful in various jurisdictions across the world. Now, in order to secure an equitable relationship with consumers, it's essential to build public trust. Thank you.
Thank you, future shapers from the University of Melbourne. So, cut off there at the ethical point. So, so Venue, how do you feel about that? Can I pass to the judges, please?
Yeah, fantastic presentation. I'm interested in, just your thoughts around the time that it would take to get, I guess, the regulatory and policy changes in place so that your project is up and running and flourishing. Any comments that you've got about that?
I can start first. So through this Chemeca, we learned that if we want to get close to net zero emissions anytime soon by 2030, we do need drastic changes, which includes adoptions of new technology as well as policy changes. So if we want to stick to the net zero target by 2030, I believe that drastic policy changes right now need to happen right now.
And sorry, I might add on to that. So basically, our solution is for the energy transition period. Like right now, the hydrogen is not ready, and the policy changes around that is really slow, unfortunately. So like the policy for our project has to be starting now, in order to for the industry to start adopting our fuels.
Great presentation. Thanks very much. I'm not sure where the current diesel sources come from. Is this an import substitution or is it produced locally? And therefore, what effect it might have on existing employment patterns around the country?
Yeah, right now Australia imports most of its diesel from Singapore. Yeah, so if we're gonna implement our technology, that would mean that Australia is going to be self-sufficient in terms of production and refining of this diesel. This would definitely disrupt the existing contracts that we have with producers from other countries. But we believe that in order to transition to net zero emissions on a global scale. This is the solution. If we keep on sticking to fossil fuel-based diesel, we are not going to get any time closer to. We are not going to get any closer to the target. Is anyone else?
And just to add on to that, our diesel solution can be the diesel fuel that for our project can be implemented into current heavy machinery on the roads right now. So it will be so we don't have to replace those machinery with, say, battery or hydrogen-powered machinery. So it would be, I would say, a smoother transition than expected.
Yeah, and I think we're happy to share our IP with all the other petroleum companies just to help the society to transition faster.
Okay, do we have one last question?
What do you think is the biggest challenge to the owners of the vehicles that are running diesel now to convert to a power-to-liquid option?
Sorry, can you repeat the question again?
For the businesses that are running diesel-powered vehicles, what do you think is the biggest challenge to using a power-to-liquid solution?
With our diesel, it can be used as a drop-in fuel with minimal retrofitting. So I don't think that would be a very huge impact on existing diesel user. And in fact, this diesel has better performance in terms of emissions. For example, lower sulfur content, which is good for both the environment as well as the people working with these diesel operated equipments.
Yeah, and also in terms of the cost, so right now, as we can see, the diesel price is huge, high, like above $2, and our diesel is going to be less than that. And I think from the company perspective, that can save a lot of the cost. Then that's one of the benefits for switching to our fuel.
Yep. If I can add on also, with the feasibility study that we can, didn't catch that.
Okay, sorry guys. Thank you very much, Future Shapers. Okay, thank you. I'd now like to invite Monash Future Fuels from the University of Monash onto the stage. Thank you.
Trash to cash. If you're wondering if you heard me right the first time, don't second guess yourself. I did say trash to cash. Respected members of the panel, ladies and gentlemen, we are Monash Future Fuels. We're here to pitch our potential solution for a net zero carbon fuel to be utilized in the land-based industry and heavy machinery industry. Now, as I started saying, we believe in the potential for utilizing a waste feedstock such as biomass and plastics to convert the hydrocarbons and the long-chain hydrocarbon polymers into an energy density fuel such as hydrogen. Now, our process utilizes pyrolysis and gasification to convert this waste feedstock into hydrogen and thereafter convert it into ammonia for storage and transportation. The carbon dioxide that is produced within the system is sequestered and utilized as a feedstock to an algal pond, which then becomes a secondary feed source to our biomass.
So inherent safety design and practices are the heart of our solution. Hence, we convert the hydrogen into ammonia for storage purposes and as a hydrogen carrier. But the big question is ammonia safe for use? So we had a couple of discussions with industry experts in this conference, and who brought up these questions about the flammability and toxicity of ammonia. To overcome this challenge, we are actually cracking the ammonia to produce hydrogen back for on-site utilization, providing pure hydrogen for retail. To better visualize this, the ammonia that is produced on the site will be transported via minor pipeline networks to storage hubs, and then further to refueling stations, as well as operating sites. On request of the industry surveys, we actually conducted an LCA to compare the transportation utilization
comparing pipelines and the trucks, and found that pipelines actually, the trucks are actually better than the pipelines to transport ammonia.
So what is a smart hydrogen supply chain? Well, a biorefinery is a source for an endless amount of data points. So our smart biorefinery will utilize those data points in the form of a software platform and an industrial Internet of Things to enable operators to better visualize and control what is happening in the process. The smart aspect of our solution is that it will be utilizing artificial intelligence and the data from past, present, and forecasted future information to act on the process without human intervention. So why are we going to all of this trouble? The main benefit is lower operability costs due to optimized process management decisions. Secondly, we'll have increased scalability potential because we will be able to use a network of virtual refineries that can share physical resources such as end product, end consumers, and so on. Additionally, Rochelle Doyle raised a point in her Sunday presentation of the importance of utilizing a digital solution in chemical engineering to improve process safety, and so that's what we're doing here. The cost, of course, there is a financial aspect to this that we have to consider, and there is a cybersecurity risk that needs to be mitigated during development. And also there may be an ethical question that you may be wondering, are chemical engineers going to be replaced by artificial intelligence? The answer is a resounding no. Jobs are completely safe. We'll be helping them do their jobs better. That's the idea. So we think that the value coming from this digital twin is offset by the costs associated with it, the other way around.
And so the question is, what makes our solution stand out from all other solutions? Well, to start off, Monash Future Fuels, we are actually working on a net carbon negative fuel. Not net zero, net negative. And we'll look into numbers after this. So with that, the prospect of waste valorization actually mitigates the fact of carbon dioxide re-emissions that these wastes would actually have occurred as they sit in landfills. And the fact that we are actually incorporating a carbon capture utilization solution into our process means that we're also addressing our carbon emissions and offsetting others as well. To add to that, we've done a techno-economic analysis, and we know that our hydrogen produced is actually economically competitive in today's market, with a projected retail cost of $7.70 per kilogram of hydrogen produced. To add to that, the technology readiness of our level of siloed parts of our solution sits between TRL 6 to 8. And what we need to do is to integrate all these amazing solutions to become one cohesive one. And finally, our smart twin. It enables us to do so much more, but the most important part of this is to actually understand the trends of yesterday, to make and inform our decisions today, to then support the future transition that we need for cleaner future fuels.
As much as we dislike legalities behind design, let's talk policies. There are general gas regulations in place that encompasses hydrogen, but these aren't specific. Given that there are international standards for hydrogen, we can codify these into Australian regulations, saving policymakers time. The Guarantee of Origin scheme, which outlines the key attributes of hydrogen, along with the 45Q rule that is used for carbon capture, can be adapted, and that will allow us to get cash back with more carbon that we offset. The government also can provide some incentives. Overall, there is some stigma around hydrogen, which we can combat through the education of public and highlighting that it's no different to petrol. We can also have some strategic demonstrations to outline how it's better.
Let's quickly talk about economics. We have an estimated cost of $436 million for a 65 kiloton per annum of hydrogen cost, which is retailing at $7.7 per kilogram of hydrogen. And considering the energy analysis, we actually found out that we are carbon negative and actually offsetting a lot more than we emit.
So we request Venue to join us and believe in our team and invest $45 million, after which we have considered a series of funding as well. We are Monash Future Fuels, making green hydrogen greener and smarter. Thank you.
So venue. Can I pass to you for some questions?
Okay, I have a quick question. Biomass is your main source. We didn't hear too much about the reliability and the volume, the potential volume of supply that you might be able to get. It's quite a controversial topic, biomass. I wondered what you feel about that and how you think that will go down.
Absolutely. Thank you for that question. So we ran our research into understanding what the demand and supply is within Victoria First Case. From the reports that we've understood, to meet the demands of just land-based and heavy machinery industries, we kind of figured out that biomass, the waste biomass, when we say waste, it is not something that is being utilized for human purposes or even fodder for animals, but waste alone is enough to actually meet the demands for these two sectors of the economy.
And just to add on to that, why we say for utilizing waste is because we do not aim to achieve, complete hydrogen takeover, be the monopoly for hydrogen production, but actually utilize the existing waste because, in the future, hydrogen will take over potentially to become the new energy source, but the waste will still be produced. So if we have technologies available today that we can make place, we will be actually making utilization of that waste.
Okay, so we do have one more question, I think.
Just a question, I guess there's a lot of moving parts and different fuels, and as David said, sources of biomass as well. Interested in your comments around and thoughts around the skills and capability and risks you're going to have to manage around, having such, so many moving parts that are going on there.
Also, to add on to that bit, we did mention that it's just not biomass, it's plastic waste as well. So to consider this, chemical engineers in today's scenario, we learn about waste valorization in our courses. So in terms of skill sets, we are well equipped to learn and just apply it with the industries trying to gain traction with waste valorization in itself. I think the skill set is already a part of our curriculum to learn and implement it. So engineers in the forefront, logistic managers to make sure that we kind of meet the demand and supply within that particular region. And as you rightly mentioned and pointed out, we have nodal structures where the digital twin comes in hand to make sure that we do not lag in any of these distribution systems that we have.
Okay, I think that's actually all the time we have for questions. So thank you, Monash, for your skills. Thank you. So I'd like to invite the final team, last but not least, P2 Future from the University of South Wales.
You may have heard that without trucks, Australia stops. But you may not have considered that without trains, Australia will also stop. Trains are the backbone of Australian industry, transporting more than 50% of Australian freight and emitting 10% of all of our nation's land emissions. Because of this, our team here at P2 Future believe that this is a critical area that must be addressed in order for Australia to move towards a carbon-neutral future.
But for those of you who took the train here today, a solution has already probably sprung to mind. This solution, electrification, however, would cost over $230 billion for Australia's vast freight rail network. So, to better harness the massive potential of our renewable solar, wind and other sources of fuel, we need to find or adapt another fuel that can be easily transported and put into our rail network. So, what is this fuel? Well, it's got 3 times the energy density of hydrogen when stored in rail isotainers. We've used it for over 100 years, and it can be easily blended into or used in existing LNG pipeline infrastructure without having to rip it all up. You may have guessed it. It's ammonia. Introducing Amrail Pilbara, our project to get ammonia into Australia's freight rail system. We'll use air and water, truly limitless resources, to produce 100 kilotons per annum of purely green ammonia powered by the sun. This will be fed over 1,600 kilometres of track in the remote northern Pilbara, to where it will be combusted in over 100 retrofitted locomotives and returned to the environment as pure air and pure water. And with the Pilbara containing over 70% of Australia's rail freight tonnes moved each year, and having the highest solar irradiation in the country, it's a perfect starting point for this rail revolution.
So to follow on from David Bogle's presentation yesterday on ethics in industry, we have made sure that ethics plays just as an important part in our design process as safety. We have interviewed key stakeholders over the past 2 days here, and one major question came out of our feedback. What are we going to do with all our nitrous oxide emissions? So to manage these, after ammonia is directly combusted, the nitrous oxide byproduct will be captured before it is catalytically converted into air that can be safely released to the atmosphere. To maintain professional and ethical integrity, we pledge to remain transparent about our emissions. Another key concern that came out of our feedback was the safety of personnel on site, as ammonia is quite toxic and is a respiratory irritant. So to account for this, we are going to automate refueling stations in addition to the already automated locomotives in the Pilbara to isolate personnel from any loss of containment events. Trains are also already more than 15 times safer than other forms of land transportation, according to a statistic by BITA. It is also very well understood with an extensive handling history and well-defined Australian standards. Because of this, the main project risks rely on ensuring the partners are on board, developing trust in our technology, and developing a framework for future fuel, transport, and industry collaboration.
And to develop this framework for future fuels, which in this project's case will remove 74 kilotons per annum of carbon dioxide, or the equivalent of taking 350 trucks off the road, we're asking for $250 million from Venue to supplement our $960 million CapEx project. A project which, by the way, is over 12 times cheaper than electrifying this section of track. Because of this, with this $250 million of support from Venue, this project will deliver a net present value of over $540 million over its 30-year lifespan, developing and producing ammonia with a levelized cost of less than $100 per gigajoule. So imagine filling up your car at the pump with a cost of 66 cents per litre. Further, beyond just financial advantages, we'll also be delivering back to local communities, including in particular those heavily integrated in WA's vast LNG and carbon infrastructure. We'll keep an open dialogue with traditional owners in the region, including attending community and land ownership meetings with the YMCA, the local land ownership council. We'll deliver over 1,500 skilled jobs in the region directly and support long-term education and engagement projects in the Northern Pilbara. Further, as the project scales up, we'll also re-skill the workers and communities surrounding the carbon infrastructure in the region, particularly those attached to LNG facilities. By upgrading and modernising these facilities, we'll be able to use them to export our green ammonia offshore.
In fact, a survey conducted by the International Maritime Organization found that 40% of the shipping industry believe that ammonia will eventually become their fuel of the future. This will allow us to take the lead as a prime refueling point on key maritime routes. It is also predicted by the International Energy Agency that ammonia demand will increase by 40% by 2050, especially as it will be instrumental in driving the emerging hydrogen revolution. As such, we will make use of an LNG-like modular plant, implementing the Design One, Build Many strategy referenced by Claire Anderson in her presentation yesterday. This will give us the ability to add extra units when the time comes for us to eventually upscale our production capacity.
And to build this scalable, safe, and sustainable fuel system, we'll also be able to exploit over 100 years of experience with ammonia, including concrete policies around ammonia storage and handling, as well as LNG and dangerous goods rail transport. However, possible next steps for the government to progress this project further in terms of policy include developing a policy system that allows for transparency across the value chain so that end users and consumers can ensure that their fuels are green. Further, a framework to allow us to collaborate further across Australia and apply the lessons learned in the Pilbara all across the country would be required. And finally, a legal framework for not only exporting our ideas, but also our liquid sunshine would help catapult this project into the future.
With this safe, sound and sustainable project ready to deliver Australia a world-first green solution, we suggest that Venue invests in catapulting Australia into our green future. Let P2 Future power your future.
Venue, I think you're going to have a really difficult choice here. So can we have some questions for the final team?
Thanks for the presentation. You've really picked ammonia for marine applications. We've seen what happens in different energy sectors when there's been a significant incident globally. The tragedy in Fukushima is one example of nuclear. Given the toxicity of ammonia and what would happen to the sea life if you had a maritime incident, how risky is your project?
So again, based on this, the ammonia is not like a new fuel. It's not a new chemical, or it's not being used in a completely new application. Ammonia has been produced for over 100 years, and it's been stored in massive quantities around the world for those 100 years. So we're able to draw on that industry experience, and as sort of mentioned in the keynote speakers yesterday, we're able to take those lessons learned and directly apply them to our project. So for instance, using double wall, double integrity storage tanks and minimizing on-site inventory as much as possible. Based on this 100 years of incident history with ammonia, we can say that our project is far, far safer than other modern renewable projects where the lessons learned are still to be learned. So because of that, we believe that our project risks are quite low.
Fantastic presentation, really impressed. I guess just following on from that, I'm keen to sort of hear about, your stakeholder management approach around gaining social licence for this sort of a project.
Social license, did you say? So I guess, as Ben mentioned, we will consult with local communities, particularly the Indigenous communities, about building such a site. And also, we don't have to clear a lot of land, and the place that we've chosen for Port Dampier is quite remote, so there won't need to be, a lot of land clearing in order to build our site. And also, the population density is quite low as well, so we won't have to deal with as many, the potential for damage to occur to communities is going to be significantly lower than if it was in a more highly populated region.
Yeah. One last question,
One last one. I was interested in the concerns about nitrous oxides and your catalytic process there, but particularly around your mention of being transparent about all emissions. How are you going to convince all the stakeholders that you're really going to stand by that? Because, we're not always well known for doing that.
Catalytically converting nitrous oxides is something that's not new. One way to persuade people is that it's already been done in cars. It's, in the vehicles that we drive every day, it's not a new technology. And also, because we're going to put the catalytic converters directly into the engines, it's not like, they'll be captured and then moved somewhere else. It's going to be all done in one smooth process.
And I think adding to that, it's sort of engaging throughout the whole life cycle and making it relatable. So explaining that the technology is just like in your cars and letting the community come and see the locomotives as they drive past their houses and see that they're capturing all the emissions and see that all through the entire life cycle of the plant from pre-startup through to decommissioning.
I think other than that also is a lot of these sort of companies sort of hide these emissions, hide in long reports that the open community sort of can't see. So I think with being transparent and perhaps having a website regarding our company where we are honest and very easily, the information's very easily accessible to the community where they can actually understand what we're doing. I think that's more important as well, because we do write a lot of reports about what we're doing, but the average person doesn't know how to interpret that.
Okay, thank you very much. Thank you, P2 Future. Thank you. Thank you, well done. Well, Benji, I have to say, they were all awesome. What a fabulous range of presentations. Can we give the teams a round of applause? So, as the audience, you can go away and enjoy some lunch. As the finalists, you need to follow you and Catherine to be interviewed. And then, unfortunately, or fortunately, then you have the really difficult choice of deciding who gets the money. So that concludes today's session, but can I get you to come back at 1:30 to hear the results of the winners of the very first Chemeca Student Hackathon? Thank you.